Today we are going to talk about correlations of graph. A scatter plot is a graph used to determine whether there is a relationship between paired data. In many real-life situations, scatter plots follow patterns that are approximately linear. If y tends to increase as x increases, then the paired data are said to have a positive correlation. If y tends to decrease as x increases, then the paired data are said to have a negative correlation. If the points show no linear pattern, then the paired data are said to have relatively no correlation. So what it's saying, if it rises from left to right, it is positive. If it lowers from left to right, it is negative. If there is no way that I could draw a line, there's no way on that one, then there's no correlation. We need to clarify here. It says describe the correlation shown by each scatter plot. It says CDs and cassette cells. Well, CDs and cassette cells from 1988 to 1966. So cassettes, there was tons of cassettes being sold earlier. Now the cassette cells are decreasing and the CD cells are increasing. So this is a negative correlation. And CDs are increasing. And then over here, CD players to CD players from 1990 to 1970. This is a positive correlation because as there's more CDs sold, there's more CDs players bought. So this is positive correlation. Same thing here. It lowers from left to right, so therefore a negative correlation. This one's a positive. It hires from left to right. And the last one, points are everywhere, so therefore negative. Therefore no correlation. It says draw a scatter plot of whether the data have a positive correlation, a negative correlation, or a relatively no correlation. Also, approximate a linear equation and find what y is at x equals 20. So to do this, we need to graph all our points. 1, 1 would be, I'm going to do the first one on number 11, so 1, 1. 2, 3. 3, 3. 3, 4. 5, 4. 5, 5. 6, 7. 7, 6. 8, 8. 9, 7. Okay, when we graph this, we realize that this is a positive correlation, so this is positive. And now we need to approximate a linear graph. What that means is we need to find a line that would go through, hit enough points to make it look as if we're good, and I would say that would. Okay, and this one has a y-intercept here at 0. A slope of, it looks like 1. Therefore, my graph would be y equals mx plus b, or y equals 1x plus 0, or y equals x. And there's that. And we need to approximate when x equals 0. So when x equals 20. So if x equals 20, y equals 20. So the point would be 20, 20. Okay, now we're going to do the other one. Go 1, 8. 1, 2, 3, 4, 5, 6, 7, 8. One, 2. 3, 5. 4, 8. 4, 3. 5, 5. 6, 7. 8, 8. 9, 7. There's no, you look at this, I can't draw a line that best fits this, therefore no correlation. If there's no correlation, we cannot approximate what y would equal if x equals 20. All right, the last one here, we got -2, -1. 4, 3. 0, 2.5. 0.5, 2.5. 1, 2. 2.5. 2.5, -1. 3.5, -3. 4, -2.5. And 5, -2.5. And again, no correlation, therefore we cannot approximate. All right, we're going to do one more. We got 12, 100. So we're going to scale this graph here. Matter of fact, let me just get a different graph. Now our graph is scaled by tens. So we go to 12, 100. Okay, which would be right here. And then 25, 75. 36, 52. 50, 26. 64, 9. Okay, and now we need to do a line best fit. Now we're going to draw a line best fit. When we do that, we come up through here. We try to hit all of our points. Okay, go down to an x intercept and a y-intercept. Our y-intercept looks about 120. Our x-intercept looks about 75. So that would mean that our slope is a rise of negative 120 over 75, since it's a negative slope. Okay, our y-intercept we stated was 120. Our negative 120 over 75 reduces to, when you reduce this, you end up with 24 over, and then 5 goes into 75 15 times. And so that is your slope, 24 over 15. So our equation would be y equals mx plus b, or 24, negative 24, over 15, x plus 120. Now you need to plug in when x equals 20, and you end up with y equals negative 24 over 15 times 20 plus 120. End up with y equals 88. So you end up with the point 2088. And this was a negative correlation. Okay, again, we're going to decide what these are: a positive, negative, or no correlation. This one's a positive, negative, no. And then we need to decide what kind of slope we have. A negative 1/2 slope, okay, is going to be a very shallow negative slope. Okay, and we're just we're just kind of putting one of these slopes with it. This is not an approximation of what we would think. So I would think that a 1-to-1 for this would be like this, probably, and a 1/2 would be like this. So therefore, we're going to say m equals 1. In this one, okay, again, a negative 1/2 would be like this. A positive 1 would be a negative 1 would be like that. So again, we're going to say negative 1. And then the last one has no correlation, therefore no slope.